reaching the beginning of the end, and we spent, well, 2 days looking at alternative, non-mainstream, disruptive technologies. And we thought, what better way to wrap it up than to get a few representatives from the industry, get a few language inventors in front row, and have them grill each other. If we look at history, well, the lesson we learn from history is that we learn nothing from history. In computer science, we seem to be taking 2 steps forward, 1 step back, and the step back is usually going in and reinventing the wheel, trying to solve problems which have already been addressed and solved, and doing so badly. And with a perspective of actual programming languages, the idea is to have a discussion over why we're making these mistakes and how do we avoid them, and what does the future entail. We've got a panel right here. Why don't you just quickly introduce each other? Or each other, yourselves.
I'll introduce Stefik, I guess then. Yeah. I'm Chad. You wanted us to talk about what languages we use?
If you just introduce yourselves very briefly for the audience and mention what languages you use on a day-to-day basis.
I'm Chad, and I work at Wunderlist, and I used to be a Ruby guy, so that's what the way people think of me. And actually, when he met me the other day, he said, "I heard you're really into Ruby," and I thought, not really, actually. I usually use, in a given week, Ruby, Haskell, Clojure, Scala, Go, Node, Erlang, maybe, Objective-C, etc. And it really is like that. That's me.
I'm Jessica, and I've done like 15 years of Java, but the last couple of it Scala, and now Clojure. And I play with Ruby in order to speak at Ruby conferences.
Hello. Oh, hey, it's on. Hi, Andy Stefik. I'm a professor at University of Nevada, Las Vegas. I do a lot of work on how programming languages impact human beings or communities or people of various stripes. I guess in terms of languages I use, I mostly write code in Quorum nowadays. And I mostly work on the compiler for Quorum, which is written in Quorum, which probably isn't that surprising. But I've programmed in many languages for decades, so pick your poison.
Hello. I'm Victor. I work for TypeSafe. I tend to do the majority of my work in Scala nowadays, but it tends to be one of these things where one day it's a bit of Java, one day it's a bit of Bash or Apple script or something like that for some weird reason. But yeah, it tends to be a lot of different things, but majority Scala.
I'm Steve Vinoski. I work for Gotcha Technologies. Lately, a lot of my work's been in C, because I'm working on the Erlang virtual machine. So I work with Erlang, C, longtime C++ programmer, started in 1988 with that. But just a whole bunch of languages like everybody else.
Okay, so let's start with the first one. We're still having the debate between static typing versus dynamic typing. That's almost a never-ending story.
I think Stefik settled that yesterday.
I think there's a lot left we need to know, but there's a lot more evidence today than there was 5 years ago, when there was effectively none. So, well, I take that back. There's that one paper from 1977 which also showed the same thing, but that's another issue.
Does everyone agree to that?
Well, to be clear, it was that static typing improves productivity, at least after your first 3 years.
So it's actually unknown. There's no measurements between half a year and 3 years, to my knowledge. So technically, we don't have a set of examples between that half year and third. So it could be that there's like a curve and it goes up or down or something like that, but no one's ever tested it, so we have no idea. But sometime in there, we know that it flips. So.
And the static typing ones forever.
Well, there's also some exceptions. So, for example, in use of generics, sorry, I do this sometimes. I'm an academic.
Can I interrupt for a second and ask in this context
Sure.
what does static typing mean?
That's what I was just going to say. Yeah, so it depends on, you know, a lot of factors, because static typing can mean many things, you know. Static typing can mean, like, you know, really interesting Haskell syntax or something like that. And it could also mean, like, you know, generics with really crazy wildcards and all sorts of stuff. So, but most developers think about it like, I have types on my method declarations and stuff like that, right? That helps, right? So having types on your method declarations is a very strong predictor. Specifically, it predicts between 30 to 50% of variance in samples on program language. But for generics, the issue is quite different. You know, if you're writing a generic, if you're changing a class with generics in it, there's a 10-fold decrease in productivity. That's right, 10-fold. And in fact, it's only 10-fold because the study kept that on time and they cut people off. True story, it's in OOPSA. And then, but if you're using a generic, it gives you a slight bump. So, anyway.
Sorry, am I allowed to comment? I was just thinking, I'm currently working on a project that has a lot of C and a lot of Erlang in. And the number of, we're working against a common interface. And when there's a fault, about 50 times more errors are in the C than the Erlang. C is typed. Erlang is dynamically typed. This doesn't, I know I can't generalize my personal experience to the heights of research. I think if you're looking at typed language, you can't make these general sweeping statements about all typed language. I'd like to see the division between typed languages that are garbage collected, like Java, and typed languages that are not garbage collected, like C. And I think once you start partitioning it up, you won't see a clear difference. I'm kind of wondering about the thing you wish to optimize. I mean, Microsoft became the richest company in the world by producing buggy software early. So actually the desire of producing correct software late would not form the big companies like Microsoft. They're hardly likely to be interested in technologies that stop them from producing buggy software early. They want to do more of that. So I don't think you can make sweeping statements about types because there are so many languages, and the word type in polymorphic strong typing in Haskell doesn't mean the same as the word typing in C.
Well, okay, hold on. I think that you need to be a little careful because I didn't make a sweeping statement. What I said was that we ran formal peer-reviewed randomized controlled trials, right? So these are scientific experiments. These are not like me saying static typing is always better. In fact, anytime someone did say that, I said, wait, there's a caveat, there's this thing. Under this condition, it does that. Under that condition, it does that. So, I mean, be careful. There's a giant difference between I like static typing, it's better, or I like dynamic typing, it's better. It reduces bugs, it's faster, it's wonderful, I love it. And hi, we ran a randomized controlled trial with human users. We put them in a room, we measured their performance, we had it peer reviewed by scholars and experts in the area, and we published the data and the methodology. There's a huge difference between that.
But you can't infer the results from that. So could you tell me what languages, what programming languages are being used in that study?
There's about 8 studies, so you'll have to go read them.
Well, the one you're referring to, we did. You did. Which
yeah, there's about 8. That's why I said.
Oh, I see. Was it always the same languages?
No, there's a variety.
So which languages were used?
I don't remember them off the top of my head. So I said you should go read
Can
them.
you infer? And if you got results from one language, can you infer results in another language from that? Is there any studies that show that?
Across the set of studies, there's like 8 or 9 or something like that. And we get effectively the same answer every time.
Well, there's a lot more differences between C and Erlang besides typing. And C didn't score very well in the syntax studies.
No, that's absolutely true. No. Well, actually, we didn't test C in the syntax studies. We tested many C variants, right? But yeah, obviously, like, the reason why you might have bugs in a language may have any number of causes, right? You could have a memory leak in C. I mean, I'm sure that's never happened to anybody here, right? Maybe just me. But yeah, so I mean, of course, if that's what you're saying, that there's many things besides type systems that can impact your productivity, then absolutely that's true. But under scientific conditions, with reasonable tests that get looked at by scholars, it does impact your productivity under the conditions of the tests that we've done, which is true. It's factually correct.
There's also strong versus weak typing, right? That's the big difference with C and Erlang. know if you studied that, but that would probably be worth doing as well.
Isn't the real thing though, like I can't think of how many times I've had problems had nothing to do with typing. They have to do with distribution. Types don't save me across the network. They usually cause me problems across the network. You know, the problems I'm dealing with in the Erlang virtual machine, that's C code, but it's locking and concurrency. Types don't save me there. That's why I think the whole argument sort of misses the point. You know, there's other things that affect productivity and correctness and quality than static versus dynamic typing.
Yeah, that's true, of course. I mean, the point, though, is that we don't know much about what they are. Like with the example you mentioned about concurrency is good because, to my knowledge, there's only one or a small handful of studies on concurrency, and they show exactly what you just said, that if you have threads and locks, it's effectively a disaster. The specific result is by Chris Rosbach out of UT Austin. I wasn't involved in that study. But they showed, and this was, I think this was students over a cohort of 3 years, again off the top of my head, but I think they found an 8-fold increase in bugs with threads and locks versus software transactional memory. Not compared to like the Tony Hoare models, like CSP type stuff or anything like that, but nonetheless, I mean, it's not surprising to probably anyone that that's true, but nonetheless, obviously that's a huge productivity impact. But nonetheless, we've also shown that static and versus dynamic typing is also a productivity impact. It's not going to be one thing, it's going to be a whole hell of a lot of things, but we should document that so we all know, right? It helps us.
I just want to
costs money.
A comment on this that Erlang's strongly typed and C is weakly typed, but Erlang's dynamically typed and C is statically typed. So you're getting you got this a mixture of these things. So trying to work out what actually is. And I was just thinking, a comment you mentioned before, that they had to actually document or type their methods. How much you know is the actual typing of the method, or just the fact that they're forced to write down the type of the method in that sense. It maybe just a form of documentation so they can see what type it's supposed to have, rather than what type the system will then check it has. Right?
But I want to make sure I understand the question. Is the question whether if you have documentation of the type, if that helps?
Well, just a comment on the fact that seeing they are forced to write down the type of the method. How much you know is the typing itself that does, or just the fact that they're forced to document it of the type itself, right, or type of the method itself.
The physical manifestation, as in the fact that it's in the file, does actually matter.
Yeah.
I don't know, physically moving your fingers, I wouldn't think would matter, but having it in the file makes it. We've actually tested that. It does matter. If it's not in fact, let me be specific. It needs to be in the method declaration. That's the key. But it's not universal across developers. Specifically, if you have a novice, there's a let me say this carefully, 92% of novices actually screw up types in method declarations. But the thing is, if you leave them out for people with more experience, they get this negative impact of productivity. So it's one of these trade-offs where we have documented evidence that it has a negative impact on novices, but on the other hand, we don't really care because once they learn it, they get a productivity bump. So you can sort of look at it as a trade-off across a spectrum.
Yeah. No, so my comment was just how much is the actual typing itself compared to the fact you're actually writing down the type, the documentation for it. It's just a quick question.
You mean like moving your fingers or what?
No, it's that you can, as you say, it's there in the file. You can see that this method has this type.
Yeah, that
rather
does.
than the fact that
matters. Yeah. That matters.
I have a proposal, and that is that we speak at a higher level for a moment. Because we were talking about this whole 2 steps forward, 1 step back, is it? I remember like maybe a little over 10 years ago, there was this big movement in people like this conference probably would have been the people really pushing for dynamic typing against static typing, as Ruby and Python and Smalltalk and Erlang and all that stuff. And everyone was arguing about how that was the way, and you don't need, it was like strong versus weak was the big thing. We had strong dynamic typing versus, as you were saying. So now we're all sort of pushing for static typing and category theory and all this fun stuff. But and it's the same people, which is funny. And so far, it looks like the projects still suck just as bad, and the software still sucks just as bad. So maybe it's like 2 steps forward, 2 steps back in general for the things that really matter. What's that? 1.998 steps forward and back, right?
When we put together the title, we were trying to think positive.
Sorry.
Be positive. Yeah.
Well, I guess to tie in what Steve said, I think there's an interesting difference between structural static type systems and nominal static type systems, especially when it comes to concurrency stuff. Because if you need to ship around the definition of the type with the data that you send around, then it becomes trickier. So structural type systems are interesting.
I don't know of any test on that actually tried to investigate that scientifically, but maybe.
We should talk.
The pendulum seems to swing back and forth, and dynamic, static, there's a million other pendulums that move back and forth, but I think each time we learn something, and we come back with a little bit of the benefits of the other side.
Yeah, I mean, at the end of the day, what I hope happens, and I won't get my wish, but I hope it happens anyway, is that people start collecting evidence on this stuff more and more and more. Because the thing is, pendulum swings are good to a certain extent in the context of because we can explore various areas. But if we start honing down and being really specific about how we're testing this stuff and the methodologies, and we're thinking a lot more carefully. And if we do that, then when you're developing a new language, maybe you don't change an old language, but when you're developing a new one, maybe you say, okay, there's 100 papers on the impact of productivity. I've chosen that I care about that, and as such, I'm going to follow the evidence. Now, you can explicitly decide not to, but then you have the choice.
That 100 papers part, I think that applies to the point of the panel of Francesco's complaining that we re-implement the same things badly. But you know what? I don't think it's a problem, really, to do the same work again, because we might learn something new. And everybody can't read every paper. Steve, so you're from Basho. Did you see on Twitter the other day, A for Kyle's Kingsbury was ripping on React for not having read some papers?
Not React.
Well, the database doesn't read very many.
Ripping on a competitor to React, shall we say. There was a particular person that said, who needs to read all these papers? I built a database on my own. I didn't read any papers. And that wasn't a Basho person. But then, the whole debate started. But that was an interesting debate. And I think generally people said, well, you really do need to read the papers because these protocols are so hard, and Victor knows this, that you just don't want to reinvent the wheel.
But how do you find that previous work?
Ask some people that they're still, like Leslie Lamport's still around. you can ask them. But I think there were talks here, like Reed Draper gave a talk on kind of building a distributed database, and he included a piece about RPC versus messaging, had some good mentions of old RFCs from the 70s that talk about these problems in distribution. And I have a big slide deck with like 7 pages of references to old papers of distributed systems.
So going to conferences and then following the links and the
But
bibliography.
we have Google now. We have search engines. It's not like you used to have to sit in the library and actually find this stuff.
But to know how to Google it, you have to have the name for it already. That goes back to the naming talk earlier.
Well, the one thing to keep in mind too is that when I'm mentioning papers in this context is I'm talking about somebody that wants to have a language that is in production that is used by other people, which I don't think is all that many developers, but I agree with you completely that it's pretty much impossible to read all the academic papers. I mean, even as an academic, I mean, the number of papers per year that is published is far beyond, hell, the number of papers that is published in a month is probably far beyond what any human could read in a lifetime. So it's impossible.
So one thought there is that I find personally that not only reading papers, but like internalizing and sort of getting up to the speed to where the researcher was when he wrote the paper, that's a big investment. And then as you read multiple papers, you need to sort of, you need to internalize them all and to find like how they fit together. Are they sort of contradictory in any way? There's a lot of mental models and understanding that need to be recreated in each person that reads these things. And I think perhaps it's the medium that could be improved to facilitate that better.
I have an answer for this problem. All we do is you take all the good papers and put them on Stack Overflow, because everyone goes there to look for how do I write this thing. And you know, if we put it up there, problem solved.
Actually, you know, I would really love it if that happened, but unfortunately, there would be lawsuits up the wazoo because of the.
Just don't tell them.
I don't know if you know this or not, but in academia, this is how this works, and it's horribly stupid, but it's not my fault, so don't yell at me. You can yell at me, I don't care. But so what happens is, typically, the federal government or governments around the world, they pay scholars and academics to write academic papers. At academic institutions, they're usually judged on not the quality of the papers, but the number of them that they produce, which is idiotic beyond words, but it is what it is. And then, when those papers are published, they go to a publishing company, and that publishing company gets paid for the research. So think about it like this. You as a taxpayer pay money to the feds so that scholars get nothing to produce work, and then a publishing company literally takes every single dime of the revenue from it, but they contributed absolute zero to any part of the process. They literally, I swear to God this is true, they provided an upload button and you click submit. Taxpayer dollars at work. So anyway, the moral of the story is there's a lot of problems in academia, and there's lots of bullshit academic papers too. So I mean.
Yeah, we've discovered this cool system that helps with that. It's called open source.
Yeah.
Thank goodness we have the opportunity to contribute to work that's out there.
I've got a question for Viktor. I mean, you're currently working on a distributed framework for akka, and follow your tweets. Hey, I'm getting on a plane, I've got 6 academic papers to read through, and that makes flight to the States bearable, I would guess. How do you approach the work you're doing, and how do you combine new ideas with old ideas?
It's a really good question, and it's probably super hard to sort of off the cuff give an answer to that. But I think what's helped me the most is to start from scratch. Like really, don't even think about computers, especially for distributed systems. Don't even think about computers. Like how would you even solve this problem with people or like any other thing? I mean, there's a lot of moving parts that if we can remove them out of the equation, it's easier to gain an understanding before we sort of apply it to that more complicated domain. And I think that goes with a lot of research. I mean, computing is just a thing, right? I mean, an observation that I've made is that the more I learn about fundamental problems, I just start to see them everywhere. And a lot of things are not even sort of, I sort of had pigeonholed them into computing until I realized that this is like a fundamental problem. And once you understand and see the sort of what the possible solutions are or what you can't do once you have this problem, it also sort of limits or pushes your solution in a different direction. So it can save you a lot of work in learning sort of fundamental issues like queuing theory, for instance. There's a lot of things that you just see, okay, this is a queuing problem. And once you've learned about potential solutions or different solutions to this problem space, now you're equipped to solve this problem no matter what the domain where it manifests itself.
So do you think it would be better for the industry if more people spent time learning that versus learning new programming languages and stuff?
I think that's a good question. I think it needs to be, like the fundamentals, I think they need to get more fundamental. I think we might start the entry point into CS education at a too specific or too narrow level. Perhaps there is more to computer science than we sort of teach people at the beginning, because it tends to limit people. Once you set the base level, I think there's a lot of people that never sort of peer through that base level. They just build on top of it.
Do you think anyone even knows what the list of fundamentals to learn is?
That's probably, I don't think anybody has the full list.
So,
Actually, I don't. That's why I asked.
So, I don't either. Let me clarify that first. But there's two groups of scholars that are trying to adjust computer science education in the United States. I can't speak for Britain. I know that's a different system. But in the US, there's two things called ECS and which is called Exploring Computer Science. There's another one called Computer Science Principles in the US. And basically, what's happening is that in the US, there's no standardized way of doing CS education, right? There isn't a standardized high school classes. There is an AP class, it's in Java, and a lot of people like it, and a lot of people hate it, and as you would normally expect in our discipline, right? But interestingly, they have tried to come up with this list, and you can imagine the infighting about it, right? Like the number of possible topics. Some people think that you shouldn't even touch computers when you start, because that's CS Unplugged, and that's good. And then other people, they claim. And then other groups would say we should talk about big data at first. Other groups say that we should build robots at first, and effectively there's no agreement across the board. So it's a tough problem.
The fundamentals we need are probably different per person. I have a question for the audience. So say someone was going to do a talk on queuing fundamentals. They read a couple papers and wanted to share with their friends this insight that they learned that applied to everyone else. How many of you have a user group in your city or a meetup that such a presentation would be accepted at? Maybe a third. That's pretty good. So that's one way we can share this information. It feels a lot. Yeah, papers we love. That's true. That's totally one of those, and those are spreading. Yeah, and if you don't have one, you can start your own.
We've got a question here from the audience.
So following up from Andy's point about the academic publishing business and Jessica on open source, there is a big argument going on about open access in publishing. So I've got a question for the panel and the audience here. The audience here are not members of academic institutions. So can you get hold of ACM papers? Does the fact that they are generally behind a paywall, although sometimes still freely accessible on authors' web pages and so on, does that put you off? Does that stop you accessing the paper? Or do you find ways around it? Do you just Google the title and you find the copy on the author's web page anyway, and so the fact that it's behind a paywall doesn't cause you any problem? So can I ask for whom that would sort of block the paper for you? You would never find that, you'd never be able to read that paper? And who would find the paper anyway? You get it through Google. Okay, so it's less of a problem than I thought.
It's not so much finding one particular paper, that you'll always find, but it's the ability to go in and search an academic database based on keywords. And that's really, I think, what the ACM's library does. That's a real power. Well, it's better than Google, because at least the material is really focused.
I just wanted to mention that sometimes you can find really good PhD dissertations and such that aggregate together everything under a certain domain. It's often better than hunting through papers and piles of references.
I now know one person reads dissertations.
So I just want to say one of the big barriers for me is PDF as a format for papers is awful and needs to die. And it's on a practical level, I want to read a lot of papers on my way to work on my phone, and web technologies work on phones. They automatically resize to work with the device width. With reading PDFs on my phone, I've got to sort of scroll left and right all the time to get to the end of the column and back again. And I think that's a bigger barrier for me than the paywalls, although I don't like the paywalls either.
But is it a PDF problem or is it a layout problem? I personally don't like the two-column layout thing. I don't think it makes sense, but that's an issue for me at least.
Plus, when you give academics the opportunity to write single space with 2 columns on each page, you can imagine the kind of crap that gets in there, right? I mean, really, there's just so many references and some of this stuff, because it's all like, cite this person, cite that person, when sometimes it's not even necessary. Anyway, this is a whole other conversation.
Yeah,
Academic
papers
publishing.
are just one source of this information that we need to somehow spread around the industry so that we can all benefit from it when we can't possibly take it all in. There's also open source projects, for instance. How do you find, when you find yourself solving a problem, how do you go out and find how other people did it? Google. Anybody have an answer for that?
Google.
GitHub and Google. If you know the name to search for. There's one back there.
There's this thing. Was there someone else? Well, I think that the argument about having a name for something that you search for, I think this is not really an issue. Like most papers I have seen have something called keywords, and they usually get indexed. So you just, if you, I don't know, if there is some aspect of Q theory or whatever that you want to research, then you just try to describe the problem. just an observation.
Yeah, you might as well try. So a long time ago, I was writing tests, and I figured out that I could create programs that would create input for my tests, and then I wouldn't have to hard code a bunch of stuff. And I had no idea that what I was doing had a name, and that if I had known what property-based testing is, what generative testing is, or the name of quick check, which is what everybody calls it now, I really could have learned a lot from that. And, well, one thing I should have done back then was go to more conferences. But other than that, how can we educate each other, or do we?
And also, more experience reports or even research on why things doesn't work. Right? So we don't repeat the same mistakes over and over, because there is a fundamental reason why it can never work. That I would find that extremely interesting.
Yeah, actually, that's a great point, because oftentimes in academic publishing, publishing negative results is actually much harder, right? So there's the old, and the problem too is it's dangerous. Like if you run an empirical study and you find nothing, then by definition you found nothing. That doesn't necessarily mean it doesn't work, but it might. So it would be good if we reported that stuff, but oftentimes academic publishing is a big mess, so it is what it is.
I was just going to, I think of Chad's slide he showed where, what was it, 60% of all software projects failed to a certain extent. And there's, it's very, it's about 60%. And the problem is there in big, the big projects that fail really nastily. I've been involved in rather close quarters at some of those, and certainly my employer at the time, I might guess who it is, but would have never actually said that the project failed in any way. It was a great success, but due to changes in the market, had been down prioritized and wouldn't admit to any failures in this project. So they're not going to be exactly open about, because they don't want the shareholders to know about the losses that have been incurred in projects that have failed. So it's not in their interest to participate in this, and they will actively falsify. Yes, feel I think the word is.
What was on my mind when we were talking about sharing failures is that most of the interesting ones probably aren't even technical. I mean, we all know that. When it comes to doing projects, that's not the same as researching languages and so we're kind of having two conversations here. At least I'm having one. Maybe everyone else is having another one. But I think people do share things that fail a lot. But you're right. That, certainly you don't like to share your failures. You don't like to call what you've done bad. But we do it so much, it should be pretty easy to collect them. Because that's basically all we're doing all the time is failing. And then sometimes we get lucky.
Francesco, can you make this conference next year, call it FailMesh? All talks have to be about failure.
I mean, just remind me, QCon London had once 1 year track over, majestic failures in software, and I think one of the speakers was Sir Anthony Hoare, who talked about the null pointer, and he called the talk the $1 billion mistake, because he believed that's probably what ended up costing companies.
If you think about your own experiences, you guys or people in the audience, your major failures or the projects that failed or whatever, were they technical things? Like, can you think of a technical thing? People were immediately shaking their heads. There probably are some people who would say yes, but like the big failure is usually not a technical thing. Do you have a technical thing?
Well, I mean, I do. But I agree with you that most problems are technical problems, because we can sit here all day and talk about the languages and how they interact with the computer, but in the end, the underlying theory about how we get work done has nothing to do with the computer. Software is built by people, and it's the people we have to study if we want to learn how to get more work done.
If I was Google Plus, I would say +1.
But what's interesting is that it depends on to which thing you want to attribute the cost, right? Because I think it's so easy to take a technical problem attributed to the person who wrote the code.
Oh, that's not what she means. She doesn't mean that. She doesn't mean like blame the person.
It's not a person, but the system of the people working together.
Yeah, it's more like what is the definition of a technical cause, like a technical problem, or is it a human error? Like, I think it's too easy to blame humans as well for things that should be better in terms of technology. Like, if we take the example of the Mars lander thing where it was feet and should have been meters or something like that, I would see that as a technical problem where the type system didn't check whether it was looking for meters or adding feet to meters or something like that, which would have been caught, right? But I mean, you could point and say that, okay, it was the programmer's fault. It's a human error.
That makes sense, although, like, to plug that hole, it reminds me of the way the US government plugs security holes in the airport. Like, well, one person put stuff in their shoe, so now everyone takes off their shoes. And one person had liquid, so now you can't have water, you know? Like, there would be so many of them, it ends up being asinine, you know, the way they did it. It ends up just not working, so the terrorists will just obviously go around, you know, okay, I won't put anything in my shoe anymore, no problem.
That's a really good point, because it's the boundary, the people interacting with the technical solution. A type system like F-sharps with units would have prevented a person from making that mistake. And so it goes both ways. I mean, I was nodding my head about the technical problem, but what was our technical problem? Well, really, we were using Big Couch, and it didn't work as specified. But the people problem behind that was we centered our entire project and every piece of functionality inside it around this database. What were we thinking? And we didn't property test it.
So I remember seeing some figures from, I think, the 90s on the failure rate of large projects, and it was something like 60% failed. I also saw that among successful projects, I think less than half, on average, of the requirements ever got implemented. I often wonder, are we doing better nowadays, or is it still just as bad? I can imagine that if you use an agile approach, and you never write down all your requirements in advance, well, then you're not going to find that you failed to implement more than half of them. So maybe that helps. Do you think we're doing better nowadays?
I'm glad you said that, actually, just because when you look at some of these ways that they try to measure failure, they're actually, the methodology is not as, I actually looked at this recently just because I teach software engineering, and I was reading, I'm using a new textbook this year by this fellow named Kung. It's a perfectly fine textbook, but he was mentioning some of these failure rates, and he was citing some paper from 1994, which is called, I think it was 94, called the Chaos Report, right? And they gave very similar numbers, and so I had trouble finding it, and it turns out it was I've heard this cited a million times. It turns out it was like a for-profit group. They had a vested interest because they were selling consulting fees. There were surveys to managers, but not the technical developers. So it's sort of like, I'm just imagining company X somewhere saying, yeah, well, I had all these great requirements, and the developers are like, yeah, you're an idiot, you know? So I mean, like, it's funny that even measuring failures is pretty hard, I think, and we don't even really do that very well. It's a tough thing. So.
Yeah, everyone sort of knows the Standish thing is bullshitty. It's been going for years, though. Like the one that I showed was from 2013. What makes it seem like it's worth showing to me is It's a validation of what I already know and what you already know. You know, when you're in the industry, you see that we suck, and we have continued to suck in almost exactly the same way for many, many years.
That's why I showed it to my class too. But you know, I'm just reminding everybody that it is bullshitty.
Can I, just a quick question, how much of these failures are actually caused by the fact that the original project itself was completely stupid? I mean, it was something that was guaranteed to fail from the very beginning.
No, that's exactly it. I mean, when I read the report, I'm like, I asked the same question. Literally, I swear to God, I emailed a colleague of mine in Illinois that was a friend, and I asked him almost an identical question. Were these projects just done? I mean, should they have been canceled because they were crappy projects? I mean, that would be fine, right? So, good question.
I'll just go with a quick question on failures due to technical problems versus people problems. In 2012, RBS had a major fail where they implemented an update and it broke down at NatWest and RBS, and people weren't able to withdraw cash for like, I think it was a weekend, and that was a big fail. So would you describe that as a technical failure or a process failure? And yeah, your opinions on that.
Well, I was going to say this when Victor was talking about the Mars lander as well, because I think you can look at that as a people failure as well. They didn't have a process in place to verify code. Like, I'm sure many of you have code review processes in place. And
actually, I think it's NASA. I think they use CMM, so they have it's pretty careful.
No, but I mean...
The Mars thing? Is that what you're talking about?
I mean, my argument there was you could call it a people failure.
Yeah, no, that's not. I didn't mean to interrupt. Go ahead, sorry.
But I think in that case, it's similar, right? It's like, who put these processes together? Did they practice them? Was there trial run? Was you know, you're supposed to practice. If you read like John Allspaw, DevOps type stuff, you're supposed to practice this stuff. You know, practice having an outage, practice doing an upgrade. And if you're not doing that, then how do you really think you're going to pull it off live like what you're talking about? To me, that's a process failure, a people failure.
So at one of the conferences this year, I believe it was Go to Amsterdam, both Etsy and Netflix representatives talked about the way they deal with failure is to, one, don't blame anybody. Two, everybody comes up with ways that they or their work could make that failure either less likely to happen, faster to diagnose when it does happen, less impactful when it does happen. You can fix a failure at about 18 different levels, including at the technical level, the testing level, the people level, the system level, the process level, all of them. And if you hold that kind of retrospective and really fix it at all levels, you're not just fixing that one problem, fixing a lot of things.
We've got one last question here.
One of the things that's occurred to me is that we tend to often have poor role models for people who are getting into the industry. So we might fetishize the 25-year-old Silicon Valley, male programmer who writes an iPhone app, and people look up to that, and they don't look at someone who's been in the industry for 40 years and reads papers and sort of learns slowly. So what can we do to advertise and press for better role models for people getting into the industry?
Joe in a purple velvet jacket.
Well, I've got the pictures. Super fun.
I've seen that actually. No, I'm just kidding.
That's a hard question. I mean,
pictures of you in a purple velvet jacket. I think we'll leave it at that. Okay, a big, big thank you